All right, guys. Still working our way through Chapter 2. I think we're going to be done with it pretty quickly, despite the fact that it shows us as not having gone through half of it yet. A lot of it is stuff we already know. But we haven't worked too much with strings. What a character is a numeric code that behind the scenes gets converted into a letter for us to read. And so in the computer, if there's a 67 and then it gets told to display it as a character, then that gets turned into a C. Now that's based on something called Ascii. This is assuming that we're using something called the Ascii Character Set, which is an 8-bit character set which can support, all the letters that you type on the keyboard plus a few more. But it doesn't support, Russian and Korean and this, that, and the other. So really there are other data types that you would use known as wide character sets or Unicode. But we're using Ascii, that's okay. If we pop open Visual Studio, we could print out the numeric value of a letter and find out what its Ascii code was. You can also just Google up Ascii table or Ascii chart and find out. Ascii chart. And just pick one totally at random, view image. What we see is that a capital A is a 65, a capital B is a 66, a capital C is a 67, and so on. And the lowercase letters are 32 more than that. We don't really have to remember all that, but if you've ever wondered, I'm sure that you stay up late at nights worrying about these things, how your songs are sorted on your MP3 player, well, to some extent, they're going to be sorted based on something like this. However, it would be really annoying if all your uppercase names and all your lowercase names were sorted differently. So that if you had a song list that looked like this, Born to be Wild, Call of the Wild, and then you had Baby I'ma Want You, and then you had, I don't know, Cecilia. Totally making things up. But it'd be a real drag if all the uppercase ones came before the lowercase ones, which is what would happen in a strict Ascii sorting, because all of the uppercase letters have higher or lower values than the lowercase ones. So if you sorted this, that's a 66, that's a 67, that's a 98, and that's a 99. So it would push all the uppercase, the ones that start with an uppercase one up to the top. So things that sort human entered data, where you have both uppercase and lowercase letters, try to be a little bit more intelligent than just doing a pure Ascii comparison. Let's see, we've got, no we don't. I thought Visual Studio would have been open by now. Alrighty. New project, empty project. I'm going to go grab my boilerplate, which I saved in a file called boilerplate, as I've mentioned, so I can copy and paste it. Alrighty, source files, add, new item, C++. Okay, so here I'm going to define a character. I'm just going to call it CH, and I'm going to set it equal to capital A. Now I want the integer value of that character. So I is equal to CH. Now I'm going to print that out. Cout I followed by ENDL. And it should print 65. And it did. It printed 65. If we change it to a B, it'll print a 66. If we change it to a Z, it'll be some number up in the 90s. So why do you need to know that? Well, a string is just a series of characters. So if you have the word Bob, uppercase B followed by a little o followed by a lowercase b, that somewhere behind the scenes you have the numeric values for that. I'll show you what I mean. I'm going to come up here and do add include string up to the top of my program. Down here, I'm going to make a string called name is equal to Bob. And I'm going to print out the integer version of the first character of the string, followed by ENDL. I'm going to copy that statement and paste it 2 more times so that I can print out the second and the third. And then just for grins, I'm going to print out 1 past the end of it. Now in computers, we start counting at 0 rather than 1. So that is character number 0. That's why we specified a 0 there. That O is character number 1. That B is character number 2. Character number 3, well, we're going to find out what it is. I should have commented out the first print statement because that's making things confusing. I'm going to do that. I'm going to go here to where we did cout I, and I'm going to comment that out. Run it again. And so now I'm seeing what that string made out of BOB looks like. And according to the output, capital B is a 66. A lowercase o is a 111. If I looked on the ASCII chart, I would see that that's true. The lowercase b is a 98, and you may remember I said that the lowercase letters are 32 more than the uppercase, so 66 plus 32 is 98. And then the last one is 0. What does that mean? Well, 0 is also called null. This means that inside it's being stored as a null terminated string, meaning that it's a series of characters with a 0 value at the very end, and that's how it knows that that data stops. So if you wanted to process a string, you could keep going letter by letter until you hit one that was equal to 0, and you could stop. And we don't usually do that kind of stuff in C++. That is more 1970s school C-style programming, where you deal with things entirely in character arrays, and you're always looping until you hit the 0. Why don't we do that in C++? Because we have a string class, and the string class will tell us how long the string is and let us do other manipulations to it. So character literal, and a literal is something declared between single quotes. A string is declared within double quotes. A character string is a series of values, a series of characters, terminated by a 0. Now this is showing that /0. If you need to enter a null character as a character variable type, that's how you do it. Like if I wanted to make ch here equal to null, I could change that z to a \0. And then if I printed it out, if I printed out the integer version of it, it would print out 0. Honestly, I could just do this though. I could just put a 0 there and it would behave the same way. But if you see that \0, you read it to yourself as null. So here we have the word hello, 6 characters long because 5 of them are letters, values greater than 0, and then there's a 6th one at the end. The length of this string, we would call it 5. We would say that it has 5 characters in it, but if honestly, it has one more to accommodate the /0. But the length functions do not count that /0. It's not really part of the data, it just marks the end of it. Just like the fence between 2 yards, Might not be part of the yard, but it's the dividing line between them. Okay, that's a stupid example. The street that goes between two houses is not part of either house. It's just the thing that divides it, just like that null there. The string class. We can declare string variables that hold names. We can copy values into them with the assignment operator, the equal sign. We can display them with cout. Cout followed by arrow, arrow, first name, arrow, arrow, quote, space, quote, to put a space between them, arrow, arrow, last name. If we left this out, it would mash the two names together with no space between them. Floating point data types. We've talked about these. Floats, doubles, long doubles, whatever. They're just floating point types. They can have a decimal point, and they're stored differently inside the computer than an integer is. So a single precision, a float holds 4 bytes, a double holds 8 bytes, so it can have much larger numbers. A float is accurate to about 7 digits of accuracy, so like 1.99999. After you get past about 7 of those 0.9s, it's no longer going to be accurate. Whereas a double has double that precision, usually out to about 15 characters, 15 decimal places. And then there's something called a long double, which is actually the same as a double, so you'll never want to use it. I do not understand why they haven't cleaned up these names, because we did see that a long int is actually different than a long. Floating point literals. That's when you type in a number directly into the code editing window, 31.4159, or you can use the exponent notation, 3.14159 e to the 1, 6.25 e to the negative 5. And hopefully you all remember how to read exponential notation. If the exponent is negative, you move the decimal that way. What does that way mean? To the left. So here the decimal is going to move 5 places to the left. So right now it's between the 6 and the 2, but in order to express it as non-exponential, we would move it 1, 2, 3, 4, 5 over, and so the decimal winds up there. So these two numbers are the same. This number here, 31.4159, is the same as this because the exponent is positive 1, meaning that you would move the decimal place 1 the other direction. So 3.14159 becomes 31 after it has moved the decimal over. All floating point literals are doubled by default. If you wanted to force it to be a float rather than a double, you could just tack an F onto it. The bool data type holds either true or false. If you cast a bool to an int, it would probably print out either 0 or 1. Let's prove that to ourselves, just out of total curiosity. I'm going to come down here and do cout, print me the integer value of the thing that's false. It should be a 0. Yeah, and if I change that to a true, it'll be a 1. Early languages did not have a Boolean data type. They just let you pick a variable and say, okay, if it's 0, it's false, and if it's 1, it's true. Well, what happened if you set it equal to true? Well, that was up to the programmer to decide. So later languages defined a Boolean data type so that it was restricted to either being only one of those two values. A Boolean variable can contain expressions. I'm going to erase that. We don't need that. Like if you do this, the temperature is equal to 54 degrees. Double, float, whatever it is. And then you can do bool freezing. If freezing is equal to temperature less than 32 degrees. What that does is it compares. Is temperature less than 32 degrees? If it is, then freezing is set to true. If temperature is not less than 32, then this expression evaluates to false, and so freezing becomes false. So in this case, with these three definitions, if we print out freezing, is it going to print out true or false? It's going to be false. Why is that? Because 54 is not less than 32. Determining the size of a data type. If you're curious about how big a float or a long or whatever it is, you can use size of. Let's throw a couple of those in. Cout size of long, followed by ENDL. And then follow that with just a cout of an int. Or no, let's do cout, yeah, of an int. Size of int. So the long is 8 bytes long, and the int is 4 bytes long, meaning that the long can hold much larger values. 4 bytes is enough to get you values of up to about 2 billion, plus or minus 2 billion if you're using signed integers. The values are far larger if you use 8 byte values. Go away. I keep popping you up. You don't have anything I want to see. Okay. Why is that useful? Well, it's not that useful to us at the beginning. You don't really care how big an int is. You don't really care how big a double is. But when you're dealing with arrays, which are lists of ints or lists of doubles, you may suddenly care a lot more. Variable assignments. We know how to assign a value. You use the equal sign. That's different than a declaration. What is a declaration? A declaration is when you give it a type. Here's how you declare a variable. Int item. Should be a lowercase I. But then here's how you assign it. Item equals 12. It can't be backwards. You can't say 12 is equal to item. The value always gets copied across the assignment operator from right to left, into the left-hand side. An initialization is when you give a value as you are creating it, as you're declaring it. So here, these are two steps. This value is uninitialized. It doesn't have any starting value. But we can declare another one. Int age is equal to 30. That one has been initialized. So right off the bat, it has a value as soon as it's been declared. Variable initialize it is to assign it a value when it is defined. If you're defining multiple variables on the same line, which is not really totally cool, but you could do this. X is equal to 3, Y is equal to 5, age, comma, height, comma, I don't know, number is equal to 60. There, whatever, you know. We initialized some of them. We did not initialize others. So if we try to print out height, like this, it's not going to do anything useful. Height doesn't have a value in it. In fact, when we compile it, it's going to give us a build error. Build error is uninitialized local variable used. So it's warning us. But it's doing more than warning us. It's giving us an error. Now, in some places, C++ isn't so friendly, and it'll let you go ahead and use the data even though it's uninitialized. But at least for a simple variable declaration, it does check. The compiler checks. Does this have a starting value? No. Well, then we better not try to do any calculations with it or print it out. If we wanted that code to compile, we could say height is equal to 0 or whatever, and then it would compile and work. If we look down here, I can't get it to zoom in, but the build did generate some other warnings. It says age, unreferenced local variable. We created a variable, we never gave it a value, we never used it, So the compiler is saying, oh, by the way, you have a bug. Not a bug, but maybe you ought to know. You never use that variable. Man, this is blurry. When you're looking at the error list, if the error has a number that's in the 4000s, that means it's a very minor warning. And so your program will run just fine. And you can set your compiler onto a strict mode where even 4000 level warnings will cause it to break. But, you know, the fact that we declared a variable but we never gave it a value is not, you know, worrisome enough to stop the compilation process and to make us fix it. However, if you were writing professional code, you'd want to check your error list and get rid of all the warnings. It's kind of cheesy and tacky to hand somebody some code that got warnings in it. How do we fix that one? Well, we would just remove the word age, or we would give it a value. Other languages, the compilers are more clever, and even if you gave it a value like that, if you never used it after that, it would give you a warning about it. All right, scope. The scope of the variable is where it can be accessed. I'll show you what I mean. I know we have talked about this before already. Say I have two functions. I'm going to define a function up here. It's just going to be called silly because it doesn't do anything, but it's got a variable defined in it. The variable is called goofy. We're going to give it a value. Can we print the value of goofy out? Can we do this? C out. And by the way, don't type this because this is going to be broken. Can we do that? No, because this variable does not exist down here. It is local to this function. It is a local variable, meaning it is defined within a function, not outside of it, like a global variable. And it only exists between those two braces. This is not between those two braces. We can't print goofy out. We can't access that data value. If we wanted to be able to do, we would need to declare it outside of it, or we would need a return statement to return it somehow. But as is, so the scope of this variable is limited to within this function. The scope is the braces between which it is defined. Now that does mean a few other things. If we did this, if goofy is equal to 1, declare another variable. Int Mickey is equal to 2. Then we come down here and we want to print out Mickey. Is that going to work? No, it's not going to work. It underlines Mickey. Why? It's declared there. No, it's not really. Mickey only exists here. Like you have a fence here. You know, you can't get out of it. You can't get that value out of it. If you wanted to be able to access Mickey down here, you better declare it above your if statement, because right now his scope is limited to that. Just like Goofy's scope is limited to that. So the scope of a variable is from where it is defined all the way to the closing brace within which it is defined. So anywhere between here and here, we can access Goofy. If we added another line of code up above that, well, Goofy hasn't been defined yet, so we couldn't use it. Mickey goes from where it is defined all the way to the closing brace that holds it, which is right there. So Mickey is only in scope, got your hunting rifle, between there and there. A variable cannot be used before it is defined. It cannot be used after it has fallen out of scope, after the closing brace. Arithmetic operators. Addition, subtraction, multiplication, all that stuff. Those are known as binary operators. Not binary because they deal in 2s and 1s in this case, but because they take 2 operands. Binary operators take two operands. For example, addition, multiplication, division. To get that to work, you have to add two things. Operands, 1 and 2 are the operands. Addition is the operator. So A times B. Multiplication is the operator. A and B are the operands. Are there any unary operators? Well, there's binary, which means takes two binary. There's one, the unary operator. All that is the minus, the negative sign. If you say A is equal to -3, to us, negative, the minus sign seems like it's part of the number. But to the compiler, 3 is the number, and then the hyphen is something that modifies that 3 to make it negative. So the negative symbol is known as the unary operator. Then there's the ternary operator. Well, if unary means 1, binary means 2, ternary means 3. What does that mean? Well, the unary operator just had one operand. Right there, the operator is the negative symbol, and the operand is 3. And it's kind of confusing that there's both a mathematical and arithmetic subtraction operator and an unary operator that are the same symbol. And we just kind of live with that and kind of ignore that fact. Yeah, how does it know? How does it know the difference between 3 minus 3 and 3? Anyways, yeah. Okay, so the ternary operator works like this. Say you had A, or let's keep using temperatures. Temperatures are so easy to conceptualize. The temperature is equal to -100. And we want to decide what to wear. What to wear is equal to, is the temperature less than 132 degrees? Is it colder than freezing? If so, we want to wear a coat. Else we want to wear a swimsuit. And that's kind of dumb. But we're going to pretend that this is a string, and that's an integer, or a float. This question mark is the ternary operator. There's actually two operators involved, the question mark and the colon, but there's 3 operands. There's this thing that comes before the question mark, this thing that comes after it but before the colon, and this thing that happens after the colon. And the way it reads is, if this is true, then this happens. But if this is false, this happens. So what to wear? Well, the temperature is -100. So is that true? Is temperature less than 32? Did I hear a yes?
Yes.
Yeah, it is. So what to wear becomes the first thing after the question mark. What to wear if we print it out as code. However, if we crank the thermostat up and it's now positive 100 degrees, temperature is no longer less than 32. That evaluates to false. So what to wear is no longer equal to coat. Swimsuit gets copied into what to wear. So if we print out what to wear, it would print out swimsuit. That's the way the ternary operator works. And there's another term for it that's kind of slipping my mind.
Conditional?
Yeah, the conditional operator. Then there's also modulus. We have talked about modulus, yay or nay? Modulus meaning remainder? Nope. Okay. Say you have 4 divided by 2. That's equal to 2. 4 modulus 2 is equal to 0 for reasons I'm not going to explain yet. 5 divided by 2. If these are integers, if they're rounded down, that's still equal to 2. 5 modulus 2 is equal to 1. 6 divided by 2 is equal to 3. 6 modulus 2 is equal to 0. What's going on here? The first one is the division rounded down. The second one is the remainder. 2 goes into 4 cleanly with no remainder. So 4 divided by 2 is 2. 4 modulus 2 is 0 because 4 divided by 2 is 2 with no remainder, with a remainder of 0. What about 5 divided by 2? Well, if you round it down, 5 divided by 2 is 2, but how many is left over? Yeah, like if you had to do that style of division where you put 2 and then you put that, that curly line and then the, I don't know how to draw it in this. Like that? Okay, so 2 goes into 5 how many times? 2. 2 times 2 is 4. We subtracted those and we got a remainder of, and you were right, 1. So 5 modulus 2 is 1 because 5 divided by 2 rounded down is 2 with a remainder of 1. 2 goes into 6 cleanly, evenly. There's no leftovers, so it's got a remainder of 0. What about 10 modulus 2? Well, what's 10 divided by 2? 5, right? Is it an even division, though? Does it go in cleanly? Yeah, so there's nothing left over, so 10 modulus 2 is 0. What about 11 modulus 3? Well, 3 goes into 11 how many times? 11 divided by 3 is equal to 3 with a remainder of 2. So 11 modulus 3 is 2. Why is that useful? Well, what if you wanted to do check to see if a number is even? Is a number even? If x modulus 2 is equal to 0, then print number is even. Like that. Is the number odd? If x modulus 2 is not equal to 0 or greater than, either one would work, then see out the number is odd. All right, let's go back into our little program. We're going to ask the user for a certain number of pennies. See out how many pennies do you have. Now let's create a variable called pennies, int pennies, and let's read into that value, CIN, arrow, arrow, pennies. Now let's calculate how many dollars and cents that is. Int dollars is equal to pennies divided by 100. Int cents is equal to pennies modulus 100, the remainder after you get the dollars out. Now let's just see out our information. Dollars colon, end quote, arrow, arrow, dollars, arrow, arrow, ENDL. And then see out cents, I messed that up, cents colon, quote, arrow, arrow, cents, arrow, arrow, ENDL, like that. There were build errors. Mickey is undeclared. Goofy is undeclared. Okay, great. All that stuff. Yeah. Surprise, when I'm demonstrating errors, those errors actually exist. Let's try it again. All right, how many pennies do you have? I have 653 pennies, which is equal to $6.53. So if you need to figure out, how many quarters something is, and then how many pennies would be left over after you took those quarters out, you could do the same kind of thing. Except instead of dividing and modulusing it by 100, you could divide and modulus it by 25. Let's do the same thing with eggs. See out how many eggs do you have? Slash n. Int eggs. Read that in. CIN arrow into eggs. Now we need two variables, one for dozen and one for what's left. I'm not thinking of a good name for what's left, so I'm just going to call it leftover. So int dozen is equal to eggs divided by 12. And int leftover is equal to eggs modulus 12. Now see out both of those variables. See out arrow dozen arrow quote dozen eggs slash n. See out arrow leftover arrow eggs left over slash n. How many pennies do I have? I have one. $0.01. How many eggs do I have? I have 149 eggs. It tells me that that's 12 dozen eggs with 5 eggs left over. So that's modulus. So our homework was the BMI calculator. Not due yet, due tomorrow. So did we do this one in class and then pretend it was homework, or was it actually assigned as homework?
We assigned it at the end of class.
Yeah, it was actually assigned.
Okay. So I think what I want to do is introduce the next assignment and then call class as done, but leave it open for anybody who wants to stay and work on the homework. So let's make the Dropbox for what we've typed in so far, which wasn't a whole bunch, but that's okay. We're just going to call it modulus. Pennies and eggs. Alrighty guys, your next homework assignment is kind of similar to the BMI program, but it takes more information. What BMR stands for is basal metabolic rate, how many calories you burn in a day on average. And what it needs to run is your weight in pounds, your height in feet, and your age in years, and then an activity index, which gets multiplied by your base rate. So if you're a couch potato like you would multiply by 1.2. If you're Michael Phelps and you're extra active, you would multiply by 1.9. And in between there. So here's the calculation. Assuming that the weight is in pounds and the height is in feet and the age is in years, that's the equation for calculating the basal metabolic rate. 66 plus 6.2 times weight plus 152.4 times height minus 6.8 times age. So the more you age, the less you burn. Doesn't sound fair, but whatever. Okay. And then you multiply that basal metabolic rate times your activity index to get an estimated how many calories you burn a day on average. Couch potatoes, I think we said were 1.2, so if BMR came out to be 3,000, then it would be 1.2 times 3,000, which I guess is 3,600. And if they're extra active, then you would multiply that 3,000 times 1.9, which I can't quite do in my head, but it'll be almost 6,000 a day. Now that's probably not going to happen unless you're, a 300-pound football player or something. But anyways, so sample calculation. Imagine a person with the following data. They're 153 pounds, 5.5, and they're 61. And their activity, they're sedentary, so their multiplication factor is 1.2. So the BMR for this person is, and you just plug those numbers into the calculation, like that, and you get a number. Store that in a variable called BMR, and then you do this calculation where you multiply the BMR times the activity index, and in this case the activity index of a sedentary person is 1.2, and so it estimates that on average our 5'5" tall sedentary person burns almost 1,600 calories a day. Note, all calculations are approximate. The weight really should be lean body mass. However, we will ignore that fact for now. I like the fact that it says for now because we ignore it forever. That's not like we come back and revise this. Okay, so I have written this program, and here are the sample runs from it. Now, I keep changing this over the years because the person who originally wrote it had it displayed like 2 paragraphs of welcoming information.
Yeah.
Yeah. Welcome to the Rose State, calorie calculator. I'm glad to be here of service or whatever, But anyways, this one just says, to advance your health, we will calculate how many calories you burn per day. We will need your data on weight, height, and age, and what kind of activity you do. Now, does your assignment have to print those 2 things? No, I would not count you off if you skip those 2 sentences. But you may as well. It's not like it's hard to copy and paste out of this sample run into your program. You just, put C out, not C, pit, C out, arrow, whatever. You get the idea. But then, please enter your weight in pounds and press enter. That would be your C out statement. And then you would let them type it in. So you're going to need a CIN statement into a weight variable. Please enter your height and press enter. That would be a C out. Then you would use a CIN to read that into a variable called height or HT or whatever. Please enter your age in years. So notice that these are allowing fractional values, which means that you're going to use floats or doubles, not ints. Otherwise, you would not be able to accept that their height is 5.5 feet. It'd have to be rounded off. You're either 5 feet or you're 6 feet. That would annoy people. There are activity indexes for different lifestyles. Please select yours. If we wanted to write an awesome program, we could do it a little bit better than this. But here's what this version of it does. It displays all of those options, telling them what to type in. If you have a desk job, enter 1.2. If you do light exercise, do 1.4. If you're Michael Phelps, enter 1.9. So really what would be better, and what I'm not asking for, is if this is a menu. If you have a desk job, press 1. If you do light exercise, press 2. If you do moderate, press 3. If you do hard labor in prison, press 4. Whatever.
you just do 1 equals 1.2, 2 equals 1.4, 3 equals 1.
Right. And then you have some kind of if statement that fixes it. So based on this information, what is your activity index? 1.2. Here are the results. You burn that many calories per day. Thank you for using. Okay, yeah, I don't care if you display a thank you message. And then here it runs again with different data. I'm not going to walk you through it again. I'm assuming that the calculations are correct. I haven't checked it this semester. So anyways, write and test your program. So it's pretty similar to the BMI program. It's just the calculations are more. Why are the calculations more? Because there's 4 variables involved. There's a weight, a height, an age, and then an activity multiplier. So you're going to have to ask the user for all 4 of those bits of information before you can calculate first their BMR and then the calories. So that's why I'm stopping it here, so that we have 10 minutes or so or whatever to talk about the first assignment, if you have worked on it and haven't gotten very far with it. If you haven't worked on it, then I can't help you much, but we can hang out and talk about it anyways. So go ahead and upload. I will upload this into its own Dropbox, of course. Upload what you've already done to the in-class assignment. And if you want to hang out and talk about the other one, then we can do that. All right, are there any questions? All right.